the divisible value a float or double, or you can make it like 2.0. So make it is a float. Now in this scenario, now the new compiler, they detect it using a warning division by 0. So now because I'm using a compiler version, if I want to see the version, I can use this command. So this is 11.3. So it's a new compiler. So they will detect that some kind of a logical errors with the compilers. So they can see that we try to divide the value by 0. So if I write the output to the screen, if I execute it, you will get a code down. Clear? So because I didn't save it, this should be 0, right? So early output, if you try to compile it, you will get a warning, but it will compile. But when you run it, you get a floating point exception. So another code down. So now I want you to verify whether you understood these concepts. So that means if you try to divide integer but with an integer, the output will be always an integer. So let me share that concept to the open board. So let me share that screen as well. So a window I want to share. I want to share this open board. Yeah. So here, so what I want to show you is if you divide in integer, divide by integer, so the output will be an integer format. So if you don't want to get an integer output, so you have to divide the divisible factor either a float value or double value. If you make it float, if you divide integer by float, the answer will become a float or double. So if you divide it by double, it will be double. So this is the rule. And if you divide a value by 0, you will get a code down or exception. These are the things regarding integer divisions. Is that clear, all of you? That's clear, right? So let's see what are the other things. Yeah, all of you, is it clear, right? The concept? Yeah. Yes. Okay. Yeah. So now the next thing in this CS50 is you need to mention about this if condition. So whether this is going to work. So let me share it as well. So let's share the screen again. I'll share the entire screen this time. Now this time, okay. Now what will happen if you print something like this? I'm going to have two parameters, integer y. So we will put the addition of these two. So I'm going to say x equal 5, y equal 2. I'm going to print this value by calling this function x comma y. So what will be the answer? So very simple question. Are we getting 7 or are we getting another kind of error? So this is about functions, right? So in C, you have a function and there's a rule regarding functions in C. So I hope you can see my screen, right? What will be the answer? Yeah. Are we getting 7 as output or are we getting another answer here? Or are we getting a compiler?
We might get the error because when you want to define function, you have to use def type.
You have to use what?
Type def, sorry. Uh, it may be an error. Ne?
Yeah, what
Usually
is
we
it
have to
now?
use
So because of the type diff case.
The function should be defined at the top of the page.
Yeah. So one thing is you can either cut and paste it to here. The rule is if you write the main function in the beginning, when you define function after the main function, that's one thing you have to do before you execute this program. What is
Only
that?
the first line of the
You have to
function.
copy do what? You have to copy to where? On top of the head. So that is the reason that this will show us a warning or error. The reason is if you compile a program, if you write the main method at the top, now this is a very simple rule that might be there in the exam to check whether you can understand the basic of using functions. So the rule is if you write your main method at the beginning, then the function, you must put the function prototype. This is called function prototype to the top. This should be defined in the top. Otherwise, if you don't like this kind of a scenario, you can either put this function in the beginning. So then you don't need to copy and paste this header, the function prototype. So that is the reason. Otherwise, there's no thing like you have to define a type diff. It will work without a type diff. That's not the scenario. Is that clear? Now you will see that it will compile without any problems and you can see the output as well. The 7. So is that clear? I think the question asked by...
Yeah, it's clear.
Yeah. So that's about function prototype. So what are the other things that we need to... if conditions, right? So this slide, if I want to see about conditional statements. Yeah, so if condition logics that we can write, like if, else, if. Now these are basic things. Okay. Okay, now the question is from the function prototypes. If I write a switch case like this, can I put any data here as a variable? Let's say integer, we can print it something like printf like day 1 discrete. So my question is, so in a typical switch case scenario, is it integer is the only thing allowed? What are the other data types that will be allowed in a switch case? So what are the other things allowed in the switch cases?
Char?
Yeah, so we can use a character. Instead of that, I can say char, say D, and you can put some one single Unicode character. So this can pass into that switch case. So can I use a float? If I use a float here, what will happen? So can I use float for the switch case in a C program? So you can use integers, no problems with that. So integer, short, long, those are integer data types. But if I use float or double, there might be a problem in this scenario. So let's say a equal 2.5. So if I pass this to switch case, so we have to pass it to the switch case. So what will be the case? You have to use integers. So the rule is that you need to remember regarding C in that case is you can use integer, you can use char, or you can use enums. You can't use float and double. That's the scenario regarding switch cases. in C, right? So in C, there's a little bit complicated topics. One more thing I want to show before we go to the array part. So I will write a simple function, right? So let's say test, right? So I'm going to take X here. Now this is about memory management as well. So test, I'm going to pass a parameter. Let's say K. Exactly the same prototype. What I'm going to do is I'll just make this a void function. Now it will not do anything to the screen, just printing something to the screen. So let's say void. So here what I'm going to do is I'm going to make X into 9, right? So my logic is what will happen if I pass the X to this function. So if I print after you call in the function, so what will be your answer? So are we going to get 5 to the screen, or are we going to get 9 to the screen? So read the program carefully and tell me an output. Or are we getting a compiler?
It's 5.
Just 5. Any other answers? So if it is just 5, what is the reason? We are passing 5 to the function and we are changing it to 9. So why 9 will not printing?
Yeah, when we pass into a variable into another function, it will pass by a copy.
Yeah, so that is name is called as what? Pass by value. Yeah, very good, right? That's the correct answer. So if you pass a variable to a function, no problem, it will be like this, right? So we call it as, to make a note as well, pass by reference. So sorry, not reference, it's called value, or we call it as a copy. We just pass a copy of the original value. So this 5 will be passed it to the X, but only a copy will be passed. So if I change it, only the copy will be changed, right? So now I will make this program a little bit complicated, because most of your syllabus, even up to here, right? This is from C, arrays are from C, most of the algorithms are also from C, memory management is also from C, even some of the data structures is defined in Harvard is from C. So up to week number 5 are based on C. So from week 6 onwards, you can see several new languages are introduced. So this is actually SQL, structured query language, and some JavaScript part, and this is Python API, and this is just off the topics like cybersecurity and emoji. So in that case, so I'll just put little bit weight onto the C to understand the concept behind it. So if you just pass a variable, it will be, so spelling mistakes, right? So we'll only pass it by a value. Now let's make this program a little bit complicated. So I create X as 5. I'm going to create, let's say pointer, let's say Y. Now I'm going to say pointer Y is equal to 9. Right, so then I'm going to change the prototype to take a pointer instead of a value. So now the logic is I can't pass X because we want to take a pointer. Now what will happen? Now this is a tricky question. I have the same program. Instead of a variable, I just pass a pointer. Now is it passed by a value? That is what my question is. Are we getting a compiler? So are we getting something else? Read the program, and so this is kind of output we can expect. So it's not compiler, so we can omit that. So what will happen? So we have X now. So we pass the memory address of X, not just X. So what will happen now? Shashitaran, right? So any other answers that you can see? So early scenario, the value will not change because we only put a copy. Now if you pass a memory address to the function, what will happen? Anyone? Let me share the screen for you. Ushan? Tasank? Sorry, passing the name, others. Yeah, there are answers that we put. So some get 9. So yeah, we get 2 answers. One says 9. Any other cases? So can anyone tell me a reason for this if it is 9?
The address is passed as a parameter, and the function changes the value in the address using the asterisk.
Yeah, so this is what happened, right? So let me demonstrate it using the screen share. So I'll share the entire screen. So this is what happened. So let's draw it in a graphical manner. So I will use the Gboard to clear the screen. So this is what happened. Let me clear the screen, right? So this is what happened in the scenario like this. So I'll use a pen. I'll use a red color. So I create a variable called x. So x, what is the value? Yeah, x is 5. So this store 5 there. So what really happened is this is actually created in the stack. If you follow the revision, the session that I did on memory allocation, all the variables including pointers will be created in the stack of your RAM. This is our stack. This is a smaller portion of the RAM, and heap will be a large portion of the RAM. Other than that, there are something called text memory and these things, but basically these two are the things that are available for a C program. Now this x will be created in the stack, so that will be referred as x. So the value will be, you will have memory address, let's say 0x100. So this will be storing 5 there. But the logic is we are going to create a pointer, and we are just passing a pointer to the function. So in this scenario, we create another pointer, so that will be able to store memory address of an integer. So it has a memory address called, let's say 0x200. So what I'm going to do is we are going to store the memory address of the variable 5. So that will be our x. So it will be storing 0x100 there. So now what we pass into the function is this memory address of the variable. We pass it to the function. So in that case, if we use asterisk while, so that means don't change the address. We want to see access the memory address of while, which will be our variable number 5's memory address, and change it to 9. So this will be exactly passing by reference. So we call it as this will pass by reference. So if you pass a pointer to a function and try to change it using asterisk, this will definitely update because it has a memory address of the original value. So access the function and change it to 9. So that is what we do. So is that clear to you? This concept? So remember, all the variables that you create, including the pointers, will be created in the stack, not in the heap area. So if you use memory management like malloc and calloc, then only it will be allocated in the heap area. So in this scenario, it will be passed by reference. It will be updating your original value. That clear? You can see it now, right? Yeah. So now the next thing is about arrays. So that we want to do kind of a revision, right? So arrays. Now, if you see a short there, yeah. Now the theory is, so let's note
What
it.
is a function?
So here, what they are asking, if I'm going to, now we discovered up to this. Okay, now these two will also done that. Function definition also done. Calling a function also done. Okay, let's try to do an array. Okay. So what I'm going to do is, look at this program. I'm going to create an array called A, and we'll copy this exact prototype to the top. So you can create an array like this. You can create an array like this, right? So now what I'm going to do is, we create an array called X. This will be an array 10, 5. So we can define array and assign it in technique like this. So what I'm going to do is, I'm going to set a 1 into 6. So now my question is, so we are not using any pointers. So according to the logic, so array, what will be the answer if I print a 1? So at the moment it will be number 5. So now what I'm going to do is, I'm going to call this method in the line number 7, just the reference of the array. So this is our reference in an array. So after you print it, I'm going to ask you a question like early. What will be the answer? Is it 5 or is it going to be 6? Or is it going to be a compiler? So see the pattern that we are asking questions. So a program is given and there will be options like compile errors, answers, some kind of warnings. So then you should be able to select which one is suitable for that scenario. So creating arrays, so there can be a reason for that. So in that scenario, what will be the answer? You can see an answer there created by someone. Let's see. Yeah, Fatil said that it is 5 and 5. Vihanga says 5 and 6. Some says 6, some says 5. Now the rule is, if you pass an array, so array is passed as a reference. So if you don't believe me, I will save this file and compile this program, and if I run it, you will be able to see your original value will be 5, so it will be printed in the scenario. But if you pass it to the function, the reference, the memory address will be passed to the function if you pass an array. So that means if you change that, your memory address will be accessing that and change in the access element. So in that scenario, it will be changed in that scene like that. So is that clear to you, everyone? So you have to be careful. The 3 scenarios we discussed. So what are the scenarios we discussed? So let's take a note into that text editor. We learned about arrays. So arrays, how to pass it. This will pass as a. So if you use pointers, they will pass as a reference. But if you use a variable, it will be passed as. So I'm going to ask you this scenario. Is this summary clear to you? How to pass a function as a reference like an array? If you pass a pointer to the function, it will be as a reference, and if you pass a variable, then will be only a copy will be passed. Is this three scenario clear to you? Chamod, Pati, Vihanga, Kushan, other names, Vinuka, right? Yashodha, clear, right? So summarize, right? So this is what I
Yes,
just
sir.
give you a
Clear.
summary. Yeah. So I'll give you a summarization so you can make a note, and when you study, you can use this summary as a reference point for your study practice. Because in this 2 hour, our aim is to refresh your memory about the things, concepts, in that case. Yeah. So if it is a 2-dimension arrays, you can use 2 square brackets, and you can see what will happen there. So you have to pass the array in a 2-dimensional scenarios, but I will not go into that kind of a depth. So because we don't have time to cover other aspects in that case. Okay. Since we do memory allocation sessions, yeah. So now let's quickly define something like this. So malloc, right? So we already discussed this in a session. So let's go to the memory allocation, which is about pointers, right? So I create a pointer called pointer p. Now my question is, should I use free? Is this going to give us a compiler? So if I compile this program, you get a warning. So why we get a warning here? So I just create a pointer and just freed it. What is the problem? So we learn a rule in our session. If we want to use a free method, we need some kind of a specific condition to be met. So when we can free a allocation, where we can free it? Any answers? I'll share the screen, only that screen, so you can take a look at while I look at the chat. So let me show it to you again. Yeah. So you will be able to see this one now. So why there's a problem in this case? So where should you free it? So why freeing the pointer p is actually showing us a warning? Do we have a value in the pointer at the moment? So what is the problem with this program? Yeah, so we haven't allocated dynamic memory to free. Yeah, so you have to use dynamic memory allocation technique in order to free it. So at the moment, this pointer is actually null. So this p is actually currently null. So if you try to free a null pointer, you will get this kind of output. Code out, invalid pointer, because we don't allocate anything to the string. So we have to use p equal malloc. So if you want to allocate a memory, there are 2 techniques. We learn this, and the size of the byte. So let's say 8 byte. Like this. Now we discuss, do we need to use casting operation? Should I use this casting? Is it compulsory or is it optional? The casting part is optional, right? We discussed in our session at the Calci. So we don't need to use casting because we learn this will return a void pointer. So the return type of this malloc will be a void. So void can be converted to any data type we want, like integer, double, float, any kind of a pointers. It will be automatically casted. So we call it implicit conversion will happen when you try to convert the malloc. Now in this case, if I compile it, there's a still error. So can you tell me what is one more thing we need to have if I want to use malloc function? So if I use malloc function and free function, one component should be compulsory. What should be that? So this program, one thing is missing. So that is a question that we ask you in MCQ. Yes, what is the library we have to use? If I want to use malloc and free, we have a library we have to include. What should be that? That should be our standard library. If you include that standard library.h, this will be able to mallocate with no problems. So now this is like an array. You can set values for this malloc. So now we allocate 8 bytes. So 8 bytes means I can use 2 integers. So 0 place I can put a number like 25, or you can put a float, it doesn't matter. But since this is an integer allocation, so 4 byte will be taken from the P0 and another byte P1 will be taken another value like 50. So if I compile it, no problems. If I run it, no out will be visible because we have to print it to the screen. So if you're using a pointer to print something, you can use a loop. So this is what we can do. Start with the integer I0. The best practice is you must remember the size of the memory that you are allocating in a variable. That is the standard. So I should use hash define. This is how you create a static, like mean constant variable that will be accessible in my main function. Let's say size. Let's say 8. Now we can put the size. So when you dynamically change the size, you can change it here. So we can use I less than the size, the plus plus. Here we can print the one element at a time. We can print it using this kind of a symbol. Right. So if I compile it, should be able to run. Right. Now this has a bug. Right. This program has a bug. Now can you tell me why this is a bug? We are allocating 8 bytes. Our loop is running 0 to 8. So can anyone tell me, because it's printing 25 and 15, no problem, because that is what we allocated. So you can see the screen. Look at the screen. When I run it, 25 and 15 it's allocated, no problems, because we allocated 8 bytes. So that will be each byte is 4. 25 it's allocated, no problems, printed. 15 no problem, it's allocated, it will be printed. After that, these are just dummy values, garbage values. You can see that there's a 1041 allocated because we didn't use that allocation. Clear? Because the reason is we are trying to access an element from 0 to the size of that. The size is actually 8. So it's go until 8. But this is an incorrect way of accessing the size of a dynamically allocated memory. So we learned in our revision session, there's a function we can use to calculate the size of the memory block. What should be that? So this whole loop has a bug. We learned in our lecture how to get the size of the memory block that we allocate. What should be that? Now if you use I less than 2, that is correct, but that is hard coded, right? Very good behavior, right? So if you fix this into 2, that will be correct, right? Because the size we allocating is 8 byte. So integer is actually 4. So that means 2 integer data. So that means 2 into 4 is actually 8. So then if I put 2, then it will be printing this, no problem. But if I change the size into 12, we have to again update it. So there's a technique to dynamically get the size using a calculated technique. What should be the function? Rang? Do you remember that?
Size of?
Yes, very good. So if I use size of, it will get the total size of this allocated chunk. So it will get the total size of the allocated chunk, which will be 8. But that is not the end of our calculation. If you want to get in our revision, sorry, in our lecture session also we have done that on that. So we learn something like this. Yeah, can I clear it? I think the one here is, yeah. So I will use like this. If I use size of all simple letter, this will return the size of the allocated pointer. So in this case, our pointer is actually p. So our size is 8. This will return 8. Size of will return 8. But that is not what we want. Our integer size is actually 4. So how many elements are there? If you want to get it, we need to use a logic. Okay, you can't see that, right? Because we shared a wrong screen. Look at this. You want to see the G board. Look at the screen. So if I use the size of function, it will return 8. And if I use size of to integer, it will return 4, because size of an integer is 4. If I want to calculate how many elements are in the pointer, what should be the technique? That should be a very simple division. What is that? Can Vinuka tell me? So we know a size of function to get the size of the block. We know a size of function to get the size of an integer. So if you want to get how many elements are there in the block, what should we do? We just combine these two answers now. What should we do? Kavindu? Vasindu? Anyone? It should be a very simple answer, right? Look at the screen. This logic is simple. If I use size of p, it will allocate how many bytes that are allocated. That is not what we want to do. We have to divide that answer by size of. So one integer is 4 byte. So we have size of will return 8 here. 8 divided by 4, the size will be 2. Now we don't have to worry about allocating size. If we change the size here, it will be automatically calculating the length of the integer. Is that clear to you now? So when I now run it, this will be more meaningful. Only will be printing 2 elements. And we only create it, and we don't get any stack overflows because we have only allocated 8 bytes. We only access 8 bytes. So make a note, this is how you get dynamically the size of an array size. Is that clear to you? You can clear that, right? Not a length function. You don't have a length, that is in Python. So this is how you get the size of an array. So it can be a dynamic calculate like malloc, or it can be an array that you created like this. Both technique can be applied, right? You can create an array like this as well, and you can get the size of it using the same technique. I just say size of a divided by size of int. If it is a float, size of a divided by size of float. Is that clear to you? So either a variable that's created in the stack can be accessible, or if you create it using the malloc function, that also possible. Is that clear, everyone? How to use the size of function? Yeah. Another thing I want to mention, because this we discussed, because some of you didn't participate, that is why I just quickly revising it before we go into the algorithms section, because we have how many? Yeah, around 1 hour remaining. Yeah, so the quickly I want to tell me, if I want to increase the size of this array into later, now the size we already allocate is 8. I want to allocate this into 3 elements. So we can only put 2. We want to increase the size to 3 elements. what is the function we have to use? What should be the function we have to use? So let me share that screen only, so then I can see the chat. So if I want to increase the size, because normally array size cannot be increased if you use allocation like static, but if you use dynamic memory allocation, you should be able to increase the size. Yes, very good, Ranga. It is reallocation function. So in this case, we can create a new pointer if you want. We can use the allocation for the same pointer. So I can use something like this: pointer equal. Oh, you can create a new pointer. Doesn't matter. So let's use the previous pointer. Or let's create a new pointer because that will be better. So I'm going to create a new pointer. Let's say k equal. You have to use reallocation function. So you have to use the pointer of the memory. So this will be our array we initially created, dynamically created, and you have to put the new size. So the new size will be, I want to change the size. Now if I want to increase the size into 3 element, how many bytes we have to allocate? So if I use 8, it will be 2 elements. If I want to use 3 elements, what will be the size?
12.
4. It should be 12, right?
12, yeah.
12, right? Because otherwise integer multiplication might be different, right? So we have to use 12 there. Then we can allocate it easily to the reallocation function. That I made the mistake. Ah, sorry. This is a fixed value, right? That is the problem. So in this case, we have to use a integer variable that we can dynamically change. So integer size equal 8. Because if you use hash defined tag, that will be a constant, so you can't change it again. Now it will be allocated. Now my question is, so we can ask you in an MCQ paper, should I clean the K or should I clean the P? We discussed in this session on the, we have to free which
Free
point?
K. Free
We
K.
have to, yeah, so K, not the old pointer, because all point is automatically discarded by the runtime environment, right? So it will be the operating system, they automatically discard it. So if you don't want to create, sorry, this should be an integer pointer, right? So this should not be having any compilers. Yeah. So now you can see the size will be increased to 3 and we can finally free it, right? So now my final question is, now we can do the same trick rather than using malloc. Another thing will be like calloc. But calloc is actually a little bit different from the malloc. So can you remember the difference between malloc and the calloc? So if I use calloc, what will be the difference? I'll give some time to prepare your answer.
Calloc will assign 0 as 0 to garbage values.
Yes, very good, right? Now in a paper, you will be asking question like this. So just give me a minute. So what we discussing was like in a paper, you can see a difference. Like one thing is, so if you use a malloc, if you don't assign in this step, look at this. If you don't assign the values like 0 or 1, so these two, so the difference is, if you don't initialize it, it will be a garbage value. So I think you can see the screen now. Let's share the screen again. So here what we can see is So if you use malloc, so the malloc pointer will create three. Sorry, imagine both sides are three. So three integer variables. So you can access using 0 and 1 and 2. But the values, if you don't initialize, will be some garbage value like 65, -50. So some dummy values. So you have to manually set these values into whatever the values you want to have. But if you use calloc function, it will create a dynamically generated size for you. You can use the reallocation function to increase or decrease the size. So now the difference is this will be allocating zeros automatically. We don't have to manually set to different values you like to have. So that is the advantage in calloc function. So other than that, that's one more difference. What is that? That's one more
The
difference.
syntax
Hmm? You have to put
we
the
can
how many
add.
elements you want to have, right? Very good.
Yeah.
So I can create another pointer. Let's say q equal calloc. So look at the calloc allocation. I will use the size. Now here you have to put the size in one single parameter. But in fuse calloc, you need to specify how many elements you need to have and how many elements from each size. So I'm going to say size of, I want to allocate size of so you don't have to multiply like early scenario, just size of integer into 3. So it will be automatically calculated 12 bytes. Otherwise, in a malloc scenario, we have to calculate the size and put it to the variable we want to have. Right? So just give me a second. I can see the screen, right? Yeah, sorry about it. So what we was explaining is the size allocation, right? Yeah. So now that is the end of this memory allocation. Okay, there's one thing. What are the things we discuss? Pointers we discuss. Data types. Okay, custom data types, right? Let's see some slides. Yeah. So can you tell me this type diff, right? So that is what we can see in the C. So custom data types. So that is the next thing. So now the dynamic memory allocation. The one thing we have to worry about is custom memory allocations like type diff instructors. So can you tell me why we need a type diff? Like why you need to create a type diff when you can create variables like that? Any idea regarding that? Yeah. Kalbur? Yeah. So why we need to create type definitions?
To rename data.
To rename? The main idea is actually not to rename. Like if you want to create, let's say one example, you can see this Harvard data structures. If you want to create something like this tries or hash tables or linked list, so we can create our own data type to hold these structures like try. So you can see that in our video as well. So one good example for type def. So I want you to try this, play in this tries, and here in this place, yeah, here. So this is the place that exactly show about it. So we'll quickly go to that part later. Now you can see that they want to create a data structure of their own about universities. How in this scenario they will explain about universities. Then when they have been established, like whether it is established in 1965, 1745. Likewise, you can keep their year. So the main advantage of creating a type def is you can create your own data type the way you like to have. So in this scenario, they are going to create a tribe. So they are going to keep the university inside a char character, the name of the university, and they are going to create the same structure in another tribe. So we'll talk about this in a while. So that is the main advantage. So what are the questions that we can ask you from the type def phase? So I'll show one example. Just give me a minute. Right, so just give me a minute. Just give me a minute. Where there's some guest appearing. 1 minute. Yeah, sorry about it because because of the person day there are some people are coming. That's why. Sure. Yeah. So what we was talking about is type diff, right? So here what you need to worry about is how they created a type diff, right? So one difference that you can create within type diff is, look at this, you can give a name, let's say university data, like kind of a name, and here there can be a syntax error like a semicolon or some kind of a case that it's given in the paper. So like char, so I can say name of the university. Let's say I can put some characters to store there and a semicolon. So and the structure of this, so you can store it like that. So the thing that you have to worry about is in a type def you can give a name here like test. So in a structure you will be able to see this same thing here as well. Give me a minute. Yeah, you can see it here, right? So here, look at the structure. The structure is like a type def. So there's a main difference between structure and a type def. So you can see that in MCQ question as well. So you can see structure and a type def, both you can create some data types you want to have it. And both should be defined before the main method, right? If you try to create inside the main function, what will happen? Will it combine? Like imagine you create a structure or type def inside a main function like this. So can I create it here? Is it possible? So my question is that, so anyone? So let me share that again. Look at the screen. So I'm going to create type def there. Is it allowed to create it there? Yeah, so you can't create it in our main functions because it should be defined in the outside of the main or any function scope in order to use it in our case. Okay, so we are running out of time, so we'll quickly shift to the another scenario. Right. So when you learn all those things, you will be able to cover the C basics in our CS550. So the next thing I want to show is, imagine, let's go to this algorithm parts. So this is, they might ask some theory questions regarding the data structures and algorithms. So let's start with the simple scenario. So I have some elements in an array, 2, 5, 6, 7, 8. So I want to find number 8, right? So we want to check whether number 8 is existing in this array, right? So that is the question. So the problem is, so we can ask you this kind of scenario. So in linear search, what we are going to do in this case? If you use linear search, what will happen? Anyone? Madhav? So if you use linear search, what will happen? So what is the logic in a linear?
It will search one by one.
Yeah. So you have to travel one by one in each indexes and find the element. So in a theory like this, so they might ask you, so what is the best possible scenario if you want to search 8? what is the best case? So best case is actually we treated using omega symbol. So if we ask what
Find
is
in
the
the
best
first
case?
element itself.
Yeah, find in what? The element in first index, right? If you find
First
it
element itself.
in the first
At the
place,
zeroth element.
yeah, zeroth element, that is the best case. So we can say omega will be what? 1. That clear? Yeah. So this notation you have to remember for each algorithms. So in a linear search algorithm, if you find the element in the first occurrence, that will be our best scenario because we don't have to travel the entire things, that will be there. So what will be the worst case scenario? So that will be treated using O notation, big O notation. So we will learn about this thing in another semester, this big O analysis. So, but at the moment, just think this is actually the best case scenario, omega symbol. So if we have a worst case scenario, we have to travel there. If you want to look for entire thing, what should be the notation? Yeah, you can see that as well. So we could answer. Let's see. Hey, Kushan got the answer, right? Order of n. Because we have to have that element travel the entire array. So our entire array is actually 5 elements. So this will be order of 5. If we have 4 elements, order of 4. So we can, as a generic considers, if you have n number of elements, it will be order of n. So if we can improve this algorithm, what have they designed? So which one is better than linear search? Rather than using linear search, what is a bit optimized algorithm? Anyone? It's binary search tree. So in a binary search, what we are doing? Look what happened. So if you use the same array, set of array, like this, 2, 8, 6, and 4, and we want to find 4. What is the first step in binary search? We want to look for 4. What is the first step? So this can be there in MCQ question. So pattern is given. So array is given. So we want to find using binary search. So in a binary search algorithm, what we do first? Anyone? We have to do what?
Sort it out.
Yeah. So this is not a. So in this case, this is not a sorted array. We have to sort it first, right? So some of you missed this scenario. This we can't apply for a binary search because we have to already sort the array in one of the sorting algorithms. So you can use bubble sort, merge sort, any kind of a sorting mechanism. But this you have to shift to a sorting. So this will be 2, 4, 6, 8. So this will take some time to sort, right? Now the total running time will not be like order of n. It should be the sorting time. So we can ask that in the MCQ question. So total time that will be taken to check for index number 4 will be the sorting time plus seeking time. So this will take some time based on the algorithm that you use to sort it, like bubble sort. So you have to divide the things into half and try to find it. But in this case, you have to sort it in either ascending order, descending order, depending on the way you want to find it. So once you sort it out, what is the next step? Kalpa? After you sort in this array in ascending order, what should we do? So you can see that exact example in here as well. The pseudocode also given, right? So what we need to do? What should be this? Calculate what? In a binary search, you have to get the midpoint first. So you can see the midpoint is what? Now this midpoint is index number is up to here. This is one midpoint. So this 0, 1, 2, 3. So altogether there will be 4 elements. So if you want to calculate the midpoint, 4 divided by 2. So second index will be midpoint. So this is my midpoint. Or you can say, if you sort it, this will be actually, you have to divide it by 2. The total number of elements divided by 2. Now the next thing we have to do is find that element. Now in this case, this will be second index. So if you find the element in the exact same location, you will be able to say that, okay, we found it. Otherwise, we want to go where left or right depending on the location of the place we want to find. So you can see this in this pseudocode as well. So look at here. They want to create this kind of a table initially if you want. So a target, start, end, and middle. So this is just to make things look easy for you. Now you can say this is an unsorted list. You have to sort it in one order. So this can be seen. So they have sorted it out. So we want to look for index called 19. So in that case, we want to first check for the left hand side. 19 is actually to the right hand side. So you will be able to see that the right hand side as well. So then you want to find the index to the right hand side as well. So now the question is, they might ask you is their running time. So always you have to sort it first, then find the midpoint. So once you find the midpoint, so you can see the pseudocode as well. If your target is at the midpoint, so that means if my elements that we will look is actually number 4, if the element that we looking is actually exactly at the midpoint, we stop it. So in that case, imagine 0 and 1. If I exactly find it in here, so we stop it. So actually that will be 1. So that is our best case scenario. So what will be our best case scenario if we ask you to write? Someone? Imagine we have a array, we sort it out, and we find the midpoint. So midpoint is actually 2. So if we find our element that we intend to look is actually exactly at the midpoint, what should be our best case running time? Order of what? So that will be omega, right? So in that case, it will be omega. Omega will be what?
1.
1, right? Because linear time, right? You can see it at 1 plus. So you have to carefully remember the best case. If you want to find it exactly in that scenario, we can see that omega will be 1. In a worst case scenario, you have to divide this. You need to search for left or right. So here or here, based on the division. At the worst case scenario, you have to divide all the elements. So in that case, it will be log of. Now, I'm going to ask you this question. So which one is actually having a smallest runtime? So let's say you have a big O of 1, big O of n, big O of n square, and big O of log n, and big O of n log n. So imagine there are sorting algorithms 1, 2, 3, 4, 5. Which algorithm is the fastest? Can you tell me? The running time is given. Which algorithm is fastest? So this is actually the worst case. That is why we go. So which algorithm is fastest in this scenario? Can you tell me? Anyone? 4. Alpha says 4, Kushan says 4, right? So why? So log function, if you see the log function, when the number increase, what will happen? So which one is the fastest algorithm? Is it 1 or 4? Now that's a problem, right? Because you have to understand the behavior of these two functions. This is a constant time function. Always one fixed amount of time it will take. It will not depending on the number of elements in the algorithm. Let's say if you have 100 elements, it will take 50 seconds. If you have 200 elements also, it will take 50 seconds. So if you take in terms of number of elements, which algorithm is much faster? So if you can decide an algorithm based on 1 or 4, what will be the best algorithm? Is it order of 1 or order of log n? Vihanga? Chamo, they should be order of 1 or 4.
Order of 1.
1, right? Because otherwise, because this is not depending on the number of elements. Because this will depending on the number of elements. The larger elements, the log function will reduce. So you can search in the Google as well this thing. Log function plot. So you can try to plot it, right? I think graph plotters can try to plot it. There are plotting. So this is our log function, right? So when the log function increase, so you can see it close to what? So now, so it will actually stabilize, right? You can see it's stabilized, right? It will stabilize to 1 index. So, but if it is bigger of something of 1, it will always fix. So you can say that. So if you want to choose the better algorithm, it will be this, not log n. Okay, now if I want to compare which one is better, order of log n or order of n, which one is actually the fastest? Now we reduce 1. Now we know that order of 1 is actually the one that will be not depending on the input. So we remove that. So order of n or order of log n. So you can use this plotting to do that. I think there's something called online function plotter to try it for you. So you can always use this kind of a graphing calculator to check that. So you can say log n. So let's try to plot it. Let's say base number is 10 to the power n. If you plot it, so it will be like this: y equal log. So this is our load function. So if I want to plot another expression, I can say y equal. So which algorithm is actually worst? You will be able to quickly determine by plotting this function. So I recommend before you sit for this examination, I want all of you to create a table like this, right? So something like Excel sheet. Yeah, some kind of Excel sheet. So let's say bubble short. So let's forget about sorting algorithm. Start with the searching, right? So let's say linear search. Linear search. So if I use a linear search algorithm, so you have to find their best case scenario, that will be omega of n, and so it might be different based on the algorithm. So omega and the big O. So in a linear search algorithm, the best case is omega of 1, and worst case is O of n. If it is the other algorithm, so that we discuss now, that will be binary search. So that will be binary search. So I want you to at home try to look for their best case scenario. So that will be omega of n, and worst case is log. So you can see, compared to the linear search algorithm, binary search is better because their worst case is order of n, and binary search, their worst case is log n. So if you plot them together, you will be able to see here, use a graph plotter, sorry, this one, n, when I increase the number of elements, they drastically improve, right? Look at this, they improve very drastically. But compared to the log function, they stabilize. See, it's stabilized here, right? So likewise, order of n, order of log a. So likewise, you will be able to compare their algorithm running time based on the log function. So is that clear to you, Ranga, Kalpa, Vinuka, Kushan, this thing about this algorithm running times? So I'll make a summary, right? So that is what we are going to do. So that is what we covered up here. So we learn about memory management and algorithms. So then we can go to the data structures. That's clear, right? Okay, so there are other algorithms that I want you to cover, but we have to cover everything as well, because even the Python part also we have to cover. But what I'm going to give you is, so we cover two algorithms, linear search and the binary search, and there's a sorting algorithm as well. So yeah, you can sort the thing ascending order or descending order. So I want all of you to look at it quickly, and the things that you want to find is their best case running time, and compared to the early scenario, now you can say there's a sub counter they are going to keep until the sub is done. So you have to check their worst case scenario and the best case scenario. So you try to find these things for other algorithm as well. So we are kind of running out of time, and we want to cover everything as well. So the next thing about is you want to look for data structures, right? Right? So data structures, the easiest thing you can try to create is a singly linked list. So then doubly linked list. So then you can use hash function and tries and queues and stuff. So let's try one data structure. Now there's a question they ask like this in hash function. So this is I want you to find. Look at here. They are speaking. Look at this. So this is a good place that will be asking an MCQ question. So a scenario will be given like a good hash function should, and there will be 4 answers that will be given. Like a good hash function should be use only database hash, and it should be deterministic, formula distributed, generate very different hash code, very similar data. So you can see a hash function is given. So look at this example. So if I search BART and if I hash it, so we are going to store a number inside the table like this, right? So what hash function do is, so you input some data. So when you run through that algorithm, they will return an index that should be stored. So imagine BART. So they will return a number called 6. So we are going to store the BART inside an index called 6. Now, this is a problem for a collision. So an example for a collision is this. So if I try to store Lisa here, so what will happen is Lisa also return number 6. So how do you know whether it is written 6 or 5? That is depending on the algorithm. The sample algorithm is given here, right? So this will actually total the sum together, how many characters are there, then return sum divided by the total max. So then in this scenario, it will show whether it's 6 or 5 or 3. So now we can't store Lisa in this scenario because but is already stored. So if someone asks you, so the main advantage of linear probing is you don't have to discard the bar. We can store it in the next index, right? Because if we can't store it in the index number 6, we can store it in the 7. Let's say there's another hash function, let's say Carl. So that is also returning 6. So we can't store it inside the bar because it's already stored. We can't store it inside the Lisa because it's already stored. So we have to store it in the line number 8. So we might ask you in MCQ question, so what is the downside of hash tables? What is the disadvantage of this kind of probing? So we call this storing in the next element, we call it as a probing. So we call it as linear probing to avoid collision. The collision is where you get the indexes of a function to the same point, so you can't delete the previous value, so we have to store it in the next case. So what is the main drawback of it? So our hash table should be able to see our data in an order of 1 time, right? We want to seek big O of 1, linear search. So that means we want to able to search for Bart in one lookup. So if I look for index number 6, we will be able to find, okay, Bart is there. But if you have a collision, now because of this linear probing, the problem is the number of elements will increase, right? So in 7, it will be Lisa. In 8, it will be another case. Earlier, we should be able to look for Bart in one lookup only. What will be the worst case scenario? I think you will be able to see that. What will be the scenario? So this will increase the complexity in a worst case scenario. We have to long through entire array list if we want to search, if we have a linear probing. Clear? So that kind of question may be there in linear probing. So the disadvantages of linear probing is the running time will increase. So there can be 4 answers of disadvantages of linear probing. You will be able to figure it out, and the clustering also you can see able to see that. How many minutes we have? Around that much time. So is this clear to you, all of you? Kalpa, Madhav, right? Others? Ushan, Vasindu? So you want to look for the advantages and disadvantages in this linear probing. And one example advantage is you can save your elements without having to discard the previous index. Because in this scenario, both returns number 6. We don't want to discard bar, so we can store it in the next case. But the disadvantage is if you want to search it, early scenario we can get the entire index, okay, 6, we can find the index. Now we have to find it again in the next element, then next element. So it will be increasing the complexity. So likewise, these hash tables, you will be able to see there are other structures like tries, queues, stack. You will be able to find their advantages and disadvantages and their running time that you will be able to find. So what I recommend is, so we don't have time to go to each of the individual data structures and algorithms and run their running times. What I recommend is run through them and find their worst case, and try to find a scenario where it's not applicable. So one example, if you have a large number of elements, this searching algorithm, the better thing you have to use is binary search instead of a linear search, because it will having a higher complexity in that scenario. Right, so let's try to go to the Python, because we have only few minutes, like 30 minutes, like 35-40 maximum minutes for the other things that we need to cover. Okay. So Python also, when you play this video, so one example I will be showing you is, yeah, this. Let's try to write a Python program. So I'm going to write a new file, ex1.py. right? So I'm going to say x equal input so let's quickly revise the basics of Python. Y equal input enter number 2. If I print the answer, so not printf, print, right? So what will be the case? You don't have to compile this interpreted language Python 3. So we can enter a number 25, enter a number 7. So what should be the answer? So in this case, this should be 25 plus 7, it should be 32. So why we are getting this kind of a basic concatenation 25 7? Can anyone tell me the reason?
Normally Python takes any input as string.
Right. Yes, very good. So these are string inputs. So how to overcome this problem? How do you overcome this problem? So it's string. So we have to convert it. So how to convert any strings into integer or double or float? The answer is correct, right? So your approach is correct. So you will be able to see now if you get this kind of answer and asking what will be the answer in that scenario. So what will be that? How to convert? I think we got an answer in the chat as well. Yes, end. Very good for right. Convert into int using passing methods like this. So this is an example. You can see it in the video, right? Direct example. So we can definitely suspect this kind of a question might be there as MCQ. The scenario like this. Right? Did I make a mistake? Yeah. So we have to concatenate using string operator str. So then it will be able to. Yeah. Right. So now this is also an error because you can't concatenate two integers. So you have to again convert back into string. It should be str. So is this idea clear to you? Taking inputs Python.
Sir, but the answer is not correct, no, sir. If it is concatenation, it should be 27 again.
No. In this here, 7 plus 9. We are asking the x plus y, right?
Yeah. So here x plus y is 9. Normally, if we are printing x and y, that should be 9. But here we have put str as well.
Yeah. The reason why you put str, the reason is now if you want to print it directly, no problem. You want to print without any characters, let's say answer just the number, you can try it like this. 2 and 7 should be 9, right? So the reason we need to convert the answer is what? If you want to print it like the answer is this is now a string.
Yeah.
So you can't join, right? This part is string. The right hand side is an integer. If you want to join them together, we need to convert it back to what?
String.
String.
Okay, sir. Got it.
That is why you have to use the string function.
Okay.
So earlier, if you just want to print the number only, we need to convert it. Just print x plus y, it will be printing. Okay. So if you want to print answer is this one, you have to use the again converting mechanism. That is why 2 plus 7. Now it will be printing answers. So what I want you to take from this is you want to print two numbers. If you want to do calculation, you have to use converting methods like integer, float, double. And if you want to print the answer, directly, no problems. Just print it as it is like this. No issues. Or if you want, you can print it in a variable like z equal x plus y and just print z as well. No need to convert. But if you want to mix your answer with like some output, let's say answer is 9, so then you have to use str method to convert it like this. That will be printing your answers in a formatted fashion. Is that clear? That will be clear now, right? Yeah. I think that should be. Yeah. So this is about strings. Then what is the next thing I want to cover? Data types. Okay. So then the next thing they are asking is about dictionaries, right? So they will ask question from Python dictionaries. So how do you use dictionaries in Python? So where we can create a dictionary, what is the syntax we want to create? I want to store like this. So I want to store like this, something like this. So my name is Roy and my number is like 0, 1, like some kind of a, this is my telephone number. So then another person, let's say Kasun, their telephone number is like this. So if I want to store this in a key and a value pair, you can use either two-dimensional arrays or you can use a dictionary. So there's a big advantage of using dictionaries in Python. So can you find how to create a dictionary? Anyone? Can I write a basic syntax for this? This kind of data we have to store. How to write it? This should be the option we have to use. So I can say directory. You want to store my telephone number in a directory. So what should be the syntax? Anyone? Vinuka? Palpul? So how to assign this directory a value? So we have to use equal. Now should we use for a dictionary this symbol or a curly bracket? What should be the sign we have to use in order to store those data? Name and the telephone numbers. What should we have to use? Anyone?
Curly braces.
Yeah, if you use a square bracket, that is what?
List.
Loop? Is that a loop?
No, list.
Yeah, it's a list, right? So you have to get the difference. So you can ask, okay, what will be the difference between a list and a dictionary? Rang, what will be the difference between dictionary and a list?
Dictionary is a key value pair.
You can put keys and values. Then if it is a list, what we can do?
It just store values.
Yeah, it can store values. So what is the main advantage of using a dictionary? Now, a while ago we found it's like a hash function.
We can reference to values by using that
The key,
keys.
right? Yeah. So in that case, so if I want to store my name and sorry, like the early scenario, I want to store my name and the phone number. So we can write it in a simple keyword. Just put a double quotation, the key. Let's say phone number 1. So then you put the value. So my key is actually my name. So I will be. So this is my name. So this is my key I want to access, and his phone number will be like this. 01. Sorry, like this. So then the next key you have to put a comma. So then Kasun. So that value will be. So my question is, okay, if I want to print my phone address, how to print it? How to access the key? So how to print it? How to print this dictionary? Now we have a directory. I want to print my name. So what should be the way to access it inside the print statement? I want to print the number, telephone number. So accessing the dictionaries, you have to remember how to done that. Now in the exam paper, we can ask you what will be the syntax error in a dictionary like this. So very basic question like this might be there. What is the issue? Visual is right. So that is kind of a question might be there. So you have to be careful what are the symbols that is used in the Python, because each symbol might be storing a different value. So anyone? So I want to print my name in the directory. What should we use? Directory. Then what? You want to access it? Yes. Is just directory? Now I want to print my name, that phone number. My name, phone number, not the key. I want to print the phone number. If I just print directory, you will be seeing something like this. It will show a syntax. So you want to access the key. So how to access the key in a, yes, very good, right? So you have to use this array symbol and you can use the key name. Then we can print it in the screen. Now this we have a problem. Still we have error. So how to use that? Now here the problem is you can't use leading zeros in the beginning. That is another thing, right? So you in a key value pair you can't put a zero beginning in a key. So that is what we can see here. So we can access the index using the key like this. Now the next thing is we want to teach you about loops using the same directory. Let's revise that. So how to print a directory using a loop? So we can use a for loop. So we can use one technique like key. I want to print the key, and we can say in this directory, and we have to put a colon sign. Inside that we can print, rather than printing directory verbally, here we can put the key. Then you will be able to see the values will be printed. Right. So now this is my name. That is why I printed there. So you can use a loop to print it, the elements using key. Is that clear? So this is using a for loop if you want to print it. Now the next thing is how to convert a key into uppercase. If I want to print my name, I want to print the key, I can just directly print the key only. So I want to print this key into uppercase. So we have learned in strings how to convert this into uppercases. So what will be the mechanism we can use? Anyone? How to convert this into uppercase? So let me share only that screen. So how to convert that into uppercase? Key dot upper, right? You can say you can try to put key dot. So if you want to convert into lowercase, you can try to use the lower as well. So You can see that will be able to convert into uppercase as well. Right, so these are about directories and keys. So the next thing that we have to cover in this case in Python is, so this is about the dictionaries. So in the speller section, so image recognition is actually you can use that libraries. That's not a content. They will show that you can use third-party libraries to recognize phrases like TensorFlows, Cascade libraries. So here you can use if condition. So same thing. The loop also you can try to use something like this, right? Now this is actually iteratable, right? So it can be a number or it can be a iterable like directory. So we can print something like this as well. So I can copy it. So this loop, if you want, I can use some kind of a list. So this is a list, right? We can obviously know this is a list by using this square bracket. So first one is actually a directory, second one is a list. If I print it, you will be able to access that. So it will be iterating those elements, right? Now the next thing I want to show is, so they have mentioned about through uppercase to lowercase. Now in this slide you will be able to see their, now this section they will show you about strings, like a slide like this. So you can use strings, dictionary to uppercase to lowercase, loops and libraries, and file reading and writing. So if you can trade it, so that is what we discuss in our cases. Can use to capitalize, uppercase, lowercase, and the loops that you can try to bring. Okay, now I'm going to ask you a question, right? It's a very simple question. There's a string called x equal using a loop, I want to print this basement one character by character into the screen. How to do that? So this basement string is there. We want to print it one character by one character. How to do it? So where we can use new line. How to print it one character by one character? Now we have to use for loop that. So how to print one character by one character? So we can use an index, and this can be iterable, right? Because this string is iterable, so that means it can start from here until here. You can print it using print statement. So if I print it, it will be printing one character by one character. If you want, you can print it to the uppercase, to capitalize. So these can be used. It will work in, right? You can see that one of the methods like lowercase, then like something like capitalize. So this can be used if you want to print it like I want to uppercase or capitalize, that can be used here. That can be printing here. So now what I show you is, so there can be a syntax error that will be given to scenario like this. So one example is how to capitalize it and how to take character by characters from a loop. You can try to use it. So that's about loops. Then in this calculate example, that is the same thing that we discussed, right? Concatenation operator. So then, yeah. Now this compare. Now here you can say that whether y is capital or symbol, you check both cases. Can I use an O operator in Python? if I say if x equal to let's say let's use capital B, symbol B. So can I use O gate like this? So this is a character. You can check that it is B. Is this syntax valid? Sorry. So is this if condition is working or is it going to be show an error? Someone? Why? What is there? Shows key, right? Shows key, right? What is there? So very simple logic can be. So we can give a question to confuse you like this, because the C syntaxes and Python syntaxes somewhat it's look alike, but O gate cannot be used like this in a Python program. So you have to be careful about the logics that you are using in Python. So you had to use O using this symbol. So if I want to use AND gate, you have to use AND in this way. So that you have to be used, because you can't use this operator or you can't use this operator in Python. It will be showing you a leading syntactical error. So they will show you that in this section of that video comparing strings together. In that case. Okay. So the next function is this. Yeah. So function definitions, right? So the next part is function definition, like say test, something like this. So the purpose of this function definition is you can abstract your components in a bunch of functions, just like the C. So we don't have to reuse the same code, copy paste several times. So working like this. So will this function run in Python? So nothing will be displayed to the screen. Why is that?
No function call, sir.
Very good. So you have to call it first, right? So now the problem is there a matter that whether you should call the function before the main method or after the method, just like in C? Like we discussed in the morning at 10 o'clock, we discussed same appearance in C using function prototypes. So should I call this test function after the definition or before the definition? What will happen? Where should I call? At line number 4 or at line number 1? Which call is correct? So which one is correct? I use that function. What about others? Desha? Dilisha? What about it? What about Harshani? Alba? So which one we have to implement? Whether line number 1 or line number 5? Or should both can be used in the program? Now remember, Python syntaxes are executed line by line, right? So you start from line number 1. So if I use line number 1 call, what will be the issue? Now let's try to run it and see. I'm going to remove the line number 5 and see what will happen. So they don't detect the function because it's not defined, because they don't see whether it is actually implemented. So you have to show to the Python interpreter there's a function like this. So then only you invoke it. So then only you can see, right? So likewise, in this meow example, you can see somewhere that person, the lecturer, he implement main method. Look at this. So now in C, main is a special function, but in Python it's also a special function. But if I call this in the text function, you have a problem. Now does this working? So let's call the main function at the last if we want to define it first. So will this work? Remember, you don't need a semicolon. That's not a compulsory thing in Python. So will this run output, like working, whether it is going to print something to the screen?
No, sir.
Why?
Main function is not called.
Yeah. So that's a very good approach, right? Now in a C program, we don't have to call the main function, right? Why? It's already called by the runtime environment. So it's called by when you execute in the program, because the starting point of the program is defined. The location of the main function is there. But in Python, so the one additional qualifier is because we partially type it. Now in this main case, it will be treated as another traditional function. So for a Python program, main function we have to manually call it. Right? It's like this. So then only you can see now in this case, you can run it and see. If I Python it, nothing will be displayed to the screen. But if I call the main function, then you will be able to see it's going. So this kind of a scenario we can ask you from a paper, right? So what I recommend is if you want to study, because we have like 10 or 11 lectures, you want to take notes. So as a shortcut, I would recommend you to read this note first, right? So it will show you what are the things that will be there, like Python, variables, loops, uppercase, lowercase, Xsheet statuses, phone book, comparison swap, and how to write it to a CSV file, likewise. So then, when you're watching a video, on example, if I want to look at how bubble sort will work, so I just open that sorting algorithms here, click on it. So I want to watch their transcript. Let's say this. So open the transcript. So it will show you a possible, like, okay, so where they are going to discuss about the elements and one special cases, you will be able to see from by looking at their transcript.
So are you showing something? We can't
Sorry?
see. Are you showing something?
Okay, it's not showing neither. Okay, I forgot it because I just show you the screen on that window. Now what I recommend is that what I was discussing is, now always when I click on a lecture, so they will show you some notes, right, regarding this. So in something like bubble short, what I recommend is watch through their transcript, and from this transcript you will be able to see their running time, and you will be able to see some of their special cases by looking at this cases. So then what are the things that we left to do? Yeah, SQL, right? And Flask. Now under the SQL, in this lecture and SQL sections, you will be most probably asking question from foreign keys. You will be able to see that in here as well. Primary keys, foreign keys, likewise. Now one question that might be asking, now when I use an index, so you can see in this example, I can create an index here from the title. So if I create an index, what will happen? What is the difference between if I just filter the data and if I create an index and filter the data, what is the difference? You can see the same output will be displayed. So, but the runtime is very fast. So why is that? Anyone doesn't have an idea about it. So if I use index in SQL, so what will be the idea. Look at this. Let's see this, right? Yeah, right. The reason is the reason is going to be because they are going to create a data structure based on things. So just like a list or tree, they will be ordering your data according to that. One example, they will use the hash function and hash tree to order. So in different, we will see that in the tomorrow's session. Based on different related database systems where you create data, they will use different type of data structures to order your sorting of yes, it will work exactly like that function as print, or it can be something like try. So the main disadvantage of index is it will take some time to create the index because you have to create that structure. So you will be able to see that here, right? Now this index will be created something like this. So they show that structure as well. Yeah. So these indexes will be shown in a binary structure. So when I want to look for, let's say, site header, they only look on the travel, right? So another thing that I want you to look at is yeah. So we come up with this part in the tomorrow session because this is part of the SQL that we supposed to do in the tomorrow session. Another than that, they might be asking about to create like API even. The difference between the post method and get method to create a Flask API. Can you tell me the difference between post and like this method that you are changing post to the get? What will be the main difference? Anyone? That's an idea. Difference. So that's not the problem with the security in a get method. Why is that?
It is not that encrypted. It is like those things are started in the recursive
And what will be the problem with the post method? If you see this part, you will be able to see.
Can't you hear me?
Yesterday only we created a post method. We didn't use a method. We just directly submitted to JavaScript. But now in the Flask API, they are asking in the Flask backend. So what is the main issue should be in it can also. What do I want to do? Did you anyone you can find? Yeah, I think this is different in my voice. It's my voice. What do you think? Okay, so can I try that?